So creating our unit circle, this is something that you will be assessed on because the unit circle is a tool itself to help you with other problems and future lessons that we're going to be working on. Especially for today, we're going to be using this unit circle to help us easily identify these trig ratios. And so one thing that you're going to want to be able to do is to be able to recreate this. So I've given you some templates, but again, you can always just recreate this very easily yourself. You draw a circle on a sheet of paper and just draw your two axes, your X and Y axes, and then in each quadrant, you're just going to draw 3 lines kind of close to the middle, right? That's your 30, 45, and 60 degree angles in there. And you can just do that for each of the 4 quadrants. One's right in the middle, and one a little bit less than that, one a little bit more than that. One right in the middle, a little bit more, and a little bit less. And there's your unit circle template. Okay, so you don't need a printout or anything like that, but it is nice, it keeps it clean. And when labeling the unit circle, I suggest that you start off with the degrees. That's the unit that we're familiar with. We kind of know, hey, this is 0 degrees right here. Do each of those quadrants, right? 90 degrees, 180, 270, and then bring it back around to 360. And then go through each of the ones in the middle. Right, you're 30 degrees, 45 degrees, 60 degrees. And then continue that pattern throughout the circle. Hopefully you can get that. As far as the angles and radians, that'd be the next thing for you to identify. And those ones are a little bit different. And I'm not going to go through the whole thing. This is what Friday's entire lesson was, right? You can go watch that video if you want all my strategies and tips and tricks on how to label it. But essentially, recall that 180 degrees is pi radians, and all the way around the unit circle is 2 pi radians, and you just kind of split up the pi. You just cut it into different slices, into fourths or into sixths, and you're just counting up the slices, where this would be half of a pi, right? So you're literally cutting that pi, or that 180 degrees, into two pieces. That's pi over 2. 45 degrees, that'd be pi over 4, because that's 1/4 of 180, or 1/4 of pi. And you just go around and label it, counting up all those slices. So again, check out my notes and my lessons from Friday to help you with that. But this is something that you're going to want to keep on practicing on your own outside of school. And I'll still give you, each lesson, we're probably going to start off by doing this kind of stuff, because it's something that you just need to practice a few times, and then it gets easier every time. Once you do that, then you want to do the coordinates at each angle. At all the axes, it's just 0, 1, or 1, 0, or a -1. At each of those different angles, up, down, left, to right, because this is a radius of 1 on the unit circle. So for example, here at the right, that's 1, 0, because I just went to the right 1 unit, but I didn't move up or down.
Hey, Wojciech, you're not presenting.
Oof, that's awkward.
Yeah.
Thanks for the heads up. Good thing it was just review from Friday so far. How's that?
Yeah, it's okay.
Awesome. Thank you. So then for each of these different angles, you're writing the coordinates, like 30 degrees. That's √3 over 2, 1/2. 45 degrees. It's √2 over 2, √2 over 2. 60 degrees is the same as 30, but you just switch the x and the y. So this is 1/2, √3 over 2. And then those same values all the way around the unit circle, you just have to determine which coordinate is positive and negative in each quadrant, which is a skill you've been using for years now. You know that, in quadrant 2, x is negative. In quadrant 3, x and y are both negative. And in quadrant 4, only the y coordinate is negative, x is positive. So you just label them accordingly. So it's really not too bad when you break it down like that. So we're going to be applying this today. All right, how is this useful? How are we going to use this to easily determine these trig values super duper quickly? Well, to find these exact values of trig functions, oh yes, you're probably going to want to get a notebook out, everybody. if you haven't yet. So target 9.3 was simply creating the unit circle. Target 9.4 is being able to identify the exact values of various trig functions. The easiest way to do this is by using the unit circle. That's why it's the preceding target. We can easily use the unit circle to identify the values of these trig functions using these basic properties that we went over last week. When I first constructed the unit circle and we drew that little triangle on there for example, for that 30-degree angle back on Wednesday, we determined that the cosine of that angle would be the same thing as the x-coordinate of the point at that angle on the unit circle. And so essentially the association that you want to make is your cosine of an angle is simply the x value at that degree or at that radian on the unit circle. So associate cosine with x, then you should be associating the sine of an angle with the y-coordinate. And the best way to keep those two things straight, they're just alphabetical, nice and easy. Cosine comes before sine, and x comes before y. So cosine is with the x, the sine of an angle is with the y. For tangent, two ways you can think about the tangent. You all know from SOHCAHTOA that tangent is opposite over adjacent. So if you were to draw a triangle, and that's theta, just think TOA, or tangent of that angle. Think of your first basic like 30-degree angle on the unit circle. That would go into quadrant 1. And you can just think, oh, that's the opposite over adjacent. Well, the opposite side of that triangle is vertical, so that'd be the y-coordinate. The adjacent side of that triangle is horizontal, so that'd be the x-coordinate. So it is y over x. Another way that I just remember which value is tangent, the y or the x, which one goes on top. This has nothing to do with trigonometry, but it's just something else in algebra that we frequently use. And that is our good old slope rule of rise over run, which actually still kind of applies here as a mnemonic device in a way, because rise, means up and down. And so that's like the y-coordinate. The y-coordinate is up and down. The run, well, that's your left and right. When you run horizontally along the ground. And so that's your x-coordinate. So that's just another way that I always keep straight which of the coordinates goes on top in the numerator and which is in the denominator for tangent. So I kind of just think of rise over run. Even though it's got nothing to do with slope, it still kind of helps out in this case. So we're going to be using these properties to identify the trig values at different angles around the unit circle. So when I ask you a question such as the sine of 30 degrees, in your head, I want you to kind of translate that in a way. And I want you to think of that when you see the sine of 30 degrees, you should be thinking, hey, what's the y-coordinate at 30 degrees? So from now on, when you see sine of an angle, I want you to think about the y-coordinate. Okay, that's that association that I want you to get. It's like you're translating in a way. So when I ask you for the sine of 30 degrees, what you should do is go to your unit circle, go to 30 degrees, which is down there, and think about the coordinates. All right, so that's the coordinates at 30 degrees. It's root 3 over 2, comma 1/2. And of those two values, for the sine, We want the y-coordinate. So what is the y-coordinate at 30 degrees, everybody? It's just 1/2. You can see right there, you just take the y-coordinate at 30 degrees. So if you have the unit circle, we just look right there and boom, there's your answer. Sine of 30 is 1/2. No calculator necessary. It's awesome. It is exactly 1/2 or 0.5, but the fractions are just fine themselves. All right, so I want all of you to write down the cosine of 90 degrees. I even gave you a little quadrant 1 of the unit circle there. What's the cosine of 90 degrees? Go ahead and write that down, right? Cosine of 90. And then think, all right, the cosine. Let's see, is that the x-coordinate or the y-coordinate? Or is that the y over x? By the way, if you have your unit circle, if you want to grab one from the other day, or if you've already recreated one, I put this diagram on every slide just to make it easier for me for reference, but you don't have to redraw this for every example. You should have it there already. No problem. And so I'm just using this for our reference. The cosine of 90 degrees. Cosine, is that the x or the y coordinate? It's the x coordinate, right? So it's the first number. So we go to 90 degrees, boom, it's right here. I look for the coordinate at 90 degrees, which is 0, 1, because 90 degrees is like straight up, on the y-axis, the positive y-axis. So I just went up 1 unit, but I didn't move right or left at all. So the x coordinate at 90 degrees is 0. Therefore, the cosine of 90 degrees is 0. Now, is that the same thing as a no solution? Or is 0 an actual number? It is a number. It is a value. It's got a value of 0. All right, so we do have to write that as cosine of 90 is 0. It exists. It's just nothing. All right, so you just look at the unit circle. Boom. X coordinate at 90, 0. Done. No calculator necessary. Tangent's a little bit trickier because you got that fraction. It's the y coordinate divided by the x coordinate. And sometimes whenever you're identifying the tangent ratio, you may have to rationalize the denominator. If you recall, rationalizing means when you've got a fraction with like a root sign or a square root sign in the denominator, you can't leave it there. You can't leave an irrational number in the denominator, like the square root of 2 or the square root of 3. If that happens, you have to rationalize the denominator by simply multiplying by that same root in the numerator and denominator, right on the top and bottom. Another issue that may occur with tangent that you have to be careful of is you may have an undefined solution whenever you divide by 0. Since some of our angles, some of our coordinates, I should say, have a 0 for either the x value or the y value. So based on how we set up that fraction of dividing those two coordinates, we may get a 0 in the denominator. And if that ever happens, then there would be no defined trig value at that angle. So that happens sometimes. So just be careful with tangent. In this case, I'm asking for the tangent of 150 degrees. Recall that tangent is the y-coordinate divided by the x-coordinate. So let's go to 150 degrees on our unit circle and look at the coordinate, which is right here. I've got these two values, and tangent is the y-coordinate. So take the second number, which is 1/2, and we're dividing it by the x-coordinate, which is negative square root of 3 over 2. So I even color-coded it for you. It's the y-coordinate divided by the x-coordinate. Now, we obviously don't want to leave our answer like this. This is what we called a complex fraction in our last unit. But there's a really nice, easy solution to this. If you recall, dividing by a fraction is the same as multiplying by the reciprocal. Yes, that's great. So simply take the fraction that's on the bottom, and you're going to flip it upside down and multiply it. So I'm going to take this negative root 3 over 2, and I'm going to make it a multiplication problem instead. And I'm just going to flip that fraction upside down. So I'm going to put the 2 up top and the negative root 3 in the bottom. All right, so dividing by that fraction, I'm not going to think of it that way. Instead, I'm going to multiply by the reciprocal, which is just flipping that fraction upside down. It's still negative. You don't flip the sign for the reciprocal. You just flip the fraction. And so now I'm going to multiply these two fractions together, which is really nice and easy. Because for multiplying fractions, you just multiply the numerators together, which is 1 times 2, which is 2. Then you multiply the denominators together. 2 times a negative root 3 is just a negative 2 root 3. Well, can I simplify that fraction at all? What do you see on the top and on the bottom? A 2. Yeah, I would have done this probably, just cross those 2's out right away when I flip the fraction because I see a 2 on top and a 2 on the bottom. So that leaves me with, I'm going to move down here. If the 2's cancel out, I'd be left with just a 1 in the numerator. In the denominator, all I have left is a negative square root of 3. Because the 2's canceled out, I have a 1 up top still. Because anything divided by itself equals 1. And so this would be, this is no longer a complex fraction, because I don't have 2 fractions in there anymore. It's just one single numerator and denominator. But there's still one issue, and that is we've got an irrational number in the denominator, that root 3. How do you cancel out a square root of 3? Well, what can I multiply it by? Let's multiply it by itself, right? Because the root 3 times like another root 3 is just a 3. So that goes back to our units on radicals. So I'm multiplying by root 3 over root 3, which gives us, now there is a negative sign there. I'm just going to write the negative out in front. Doesn't matter if the negative sign is with the denominator or with the numerator in a fraction. You can just bring that single negative sign out in front. 1 times root 3 is root 3. That's up top in the numerator. In the denominator, I've got the square root of 3 times another square root of 3. That's just going to be a 3. So that would be our final exact value of the tangent at 150 degrees. Negative square root of 3 over 3. It's not a complex fraction, and it doesn't have an irrational denominator. So that's how we would want that answer to be. Now, was this a lot of work, anybody? Was this like crazy difficult? Stop nodding. It was not that difficult. Aren't these all skills that we've already done earlier in the year? Multiplying by reciprocals or rationalizing denominators? None of that is new. You've all assessed on that earlier this year already. We've learned that. That's in the past. You know how to do this already. So it's not really any type of new skill here. The only new thing is recognizing that tangent is the y-coordinate divided by the x-coordinate. That's the only new piece that you need to learn today. All right, I'd like you all to try to identify the tangent at 90 degrees. Go ahead. This is your next example. Dun, dun, dun. The tangent at 90 degrees. I just did a tangent for you, so that should be pretty familiar. Tangent at 90. Again, you can look at my unit circle up on the board. Look at those coordinates at 90 degrees and then think tangent. Which coordinate is tangent? Is that x or y, or is that a combination of the two? All right, 90 degrees. The coordinate at 90 is 0, 1. Tangent, we've also already established, is the y coordinate divided by the x coordinate. Well, the y coordinate at 90 is 1. The x coordinate at 90 is 0. So we get the fraction 1 divided by 0. Are we allowed to divide by 0, though? We're not, so what should we write instead? Since we can't divide by 0, the tangent of 90 degrees is undefined. This is similar to a no solution thing, but because this isn't an equation like with an x in it, we're not solving for x, we wouldn't say no solution. Like it's not that there's no solution to the equation. Instead, I'm asking you, what is the tangent of 90 degrees? And you're just telling me, oh, the tangent of 90 is undefined. There is no tangent of 90 degrees. So that's where we would write that. And then don't forget that angles, you're going to see them in radians as well as degrees, right? This is the new thing. That's why I started off with degrees, because that's what we're familiar with and comfortable with. But here we should also be able to identify all three of those trig ratios, sine, cosine, and tangent, for an angle in degrees or in radians. But the same rules apply. So here I'm asking you for the sine, cosine, and tangent of the angle 4 pi over 3. Now you're just not used to seeing things written as like 4 pi over 3, but that's just an angle. That's right on the unit circle. So where is this angle is what we're looking for. If I want the sine at that angle, well, just remember that sine, that's your y coordinate. So all this is asking is, what's the y coordinate at 4 pi over 3? We go over to the unit circle, look for 4 pi over 3. There it is right there. That's actually the same as a 240 degree angle. So you can think of this almost as, hey, what's the sine of 240 degrees? It's the exact same question. It's just the measurement, that angle measurement, was given in a different unit. Still the same angle. The sine of that angle is simply the y coordinate right there. So we're going to look at this coordinate, negative 1/2 comma negative root 3 over 2. So the sine at that angle is just the y coordinate, negative root 3 over 2. And that's the exact value at that angle. If in your calculator you typed in sine of 4 pi over 3, you would get a decimal approximation of negative root 3 over 2. But this is its exact value without having to round or estimate. The cosine at 4 pi over 3, that's just the x coordinate, right? Cosine means x because it comes earlier alphabetically. So let's look at the x coordinate. Well, that's just a negative 1/2. And finally, the tangent at 4 pi over 3. Well, that's one of those fractions. You're going to take the y coordinate divided by the x coordinate. So the y coordinate at that angle is the negative root 3 over 2. I'm just going to write this over here where we have more space. Divided by the x coordinate, which is negative 1/2. Go ahead and simplify that fraction for me in your notes. What is the tangent of 4 pi over 3? I've written out the start of it. Can you simplify that for me all the way? Nice. There's two negatives, though. Yeah, super close. Dividing by a fraction is the same as multiplying by the reciprocal. They're both negative, though, because it's in quadrant 3. So the first negative divided by negative. And what is the square root of 1? It's just 1. And if you have anything divided by 1, it's just itself. So you can just write that numerator. And you're good to go. All right, so if I multiplied by the reciprocal, they'd be multiplying by negative 2 over 1, because that's the reciprocal of 1 over 2. From here, the 2's would cancel out, right? I have a 2 on top and a 2 on bottom. I also have a negative times a negative, which turns into a positive. So all I'm left with is a positive square root of 3 over 1. I don't need to write the divided by 1, because anything divided by 1 is just itself. So this angle would just be the square root of 3, or this value, I should say. So the tangent at 4 pi over 3 is just the square root of 3. Any questions on these? Do you see how we are using the unit circle to calculate these? Nice and easy? Okay. So I guess that's it, right? Those are all the trig functions we know. All we know are a sine, a cosine, and a tangent, right? There are no other trig functions that we've learned. Wait a minute. Are there other trig functions besides sine, cosine, and tangent? Dun, 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 dun. Reciprocal trig functions! Yay! I know, this is so exciting. Look at all those smiles. I'm just assuming you're all smiling right now. Some of you are. Okay, maybe one of you are. Remember Choshikal? Don't, no, this isn't real. This isn't real. Shh, don't tell anyone. Let me know if like a teacher's walking by so I can cover that up real quick. Choshikal. All right, so we do have 3 reciprocal trig functions. All right, so these reciprocal trig functions. We can also identify these reciprocal trig function values by using the unit circle. These reciprocal trig functions were called cosecant, secant, and cotangent. And if you recall, what the values of these were, each of these new trig functions were just reciprocals of your classic favorite trig functions. So like over here, the cosecant of an angle is just the reciprocal of the sine at the angle. And so instead of the sine, it's 1 over sine. That's what the reciprocal means. You're just flipping it. And since the sine of an angle was the opposite over the hypotenuse, then the cosecant is the hypotenuse over the opposite. You're just flipping the numerators with the denominators. So what's this mean in terms of the unit circle? Well, you should have all those ratios written down already from previous lessons or whatever, or remember the reciprocal thing. I always keep it straight. If this starts with a C, its reciprocal starts with an S. For secant, cosecant, sine, and cosine, right? There's always one version with like a co or a C. The other one starts with an S. And then the two tangents go together, right? Tangent and cotangent. Obviously, they both have the same word, so they go together. Those are each other's reciprocals. All right, so using the unit circle for these. So if I ask you for the cosecant of an angle, what's that mean? What are we doing? Well, all these reciprocal trig functions, since they are related to your basic trig functions, sine, cosine, and tangent, and we already know what each of those sine, cosine, and tangents represent with the coordinates on the unit circle, essentially all we're doing is flipping each of those fractions, right? Since these are, by definition, just the reciprocal trig functions. So the way I think of these, if I start with secant, remember that secant is 1 over the cosine. Is cosine the x-coordinate or the y-coordinate? So I always think about that. I think secant is 1 over the cosine, and cosine is the x, right? Because c and x both come earlier alphabetically, so that's, remember how I matched those up? So the secant is simply 1 over the x-coordinate. So to do that, just take the x-coordinate at that angle, and you're just flipping that fraction. So if the x-coordinate were 1 over 2, the secant at that angle would be just 2 over 1. So it's the same angles. You don't need to memorize new like coordinates or anything like that. You're just going to flip each of them upside down. That's all. You know how all those angles were fractions like root 2 over 2 or root 3 over 2 or 1 over 2? Just flip them upside down. That's it. Cosecant, I'm thinking, okay, cosecant, that's 1 over sine. And I know that sine is the y-coordinate. That's that association we need to get in our heads. So sine is y. And so simply, if you're looking for the cosecant of an angle, take the y-coordinate and just flip that angle upside down. You're just flipping the fraction. And finally, cotangent. That's just the reciprocal of tangent. If tangent was y over x, cotangent is x over y. And so for tangent, we already were making a fraction of those two coordinates, the y divided by the x. For cotangent, you just take the x divided by the y. It's the exact same concept. It's just which coordinate's going in the numerator, which one's going to be on the denominator. That's the only difference between tangent and cotangent. By the way, my little tricks to help keep these straight for tangent and cotangent, because you know it's x and y, but which one's on top, which one's on bottom. Again, like most of these, just think alphabetical. Alphabetically, cotangent, C, comes before T, doesn't it? C is alphabetically before T, so cotangent is before tangent. And so since alphabetically this is first, so is X. So whatever the function is, that's the variable, the coordinate that goes in the numerator. Tangent, alphabetically, comes later, and Y, also in the alphabet, comes later. So that's a nice way to keep tangent and cotangent straight. Which one's X over Y, which one's Y over X. It's all alphabetical. So let's go ahead and apply this. Identify the exact value of secant of 60. So in your notes, just write secant of 60. You don't need to write this whole unit circle. You've already got that diagram. So what you might want to do to get started with these is whenever you see a trig function, one of these reciprocal trig functions like secant, is right away underneath it, write whatever its reciprocal is. So I'm thinking secant, that's 1 over cosine. And so cosine, that was the x coordinate. So go to 60 degrees. It's right here. Look at the x coordinate. It's 60 degrees. And that's 1/2. Yeah? And so then, I'm not asking for the cosine though, so I don't want 1 over 2. I want the secant, the reciprocal of it. So take that 1 over 2 and just flip it upside down. That gives you 2 over 1. It's the reciprocal of the x coordinate. Because that's what secant is. It's the reciprocal of cosine. So this is the reciprocal of the x coordinate. 2 over 1 is just 2. So the secant of 60 degrees is just 2. Do you see how this isn't really a new thing for you to learn necessarily? You're just flipping what you already know from the unit circle. It's already there for you. Just like with our basic trig functions, sometimes whenever you're flipping these, you're going to have to rationalize the denominator, right? Which just means we can't leave a root in the denominator. Just like we had with tangents sometimes, that's going to happen with a lot of these. But to rationalize a denominator, all that means is if you have for these specifically, these trig ratios, if you've got a square root in the denominator, just multiply by that exact square root in the numerator and the denominator again. And those two roots on the bottom will cancel out. So for the cosecant of 45 degrees, right away when I see one of these reciprocal trig functions like cosecant, I want to write its equivalent basic trig function. So I'm like, okay, cosecant, that's 1 over sine. Because I know sine, cosine, and tangent a lot better for like x and y or whatever. So I know that cosecant, I'm thinking of that as 1 over sine. Sine, is that x or y? The x coordinate or the y coordinate? Which one's sine? Do you remember? The y coordinate. Hopefully that's getting more and more familiar to you. So I want the reciprocal of the y coordinate at 45 degrees. Here's 45 degrees. I'm looking at the y coordinate, which is the square root of 2 over 2. But I want the reciprocal of it because this is a reciprocal trig function. So we're going to take that root 2 over 2 and flip it upside down, which makes it 2 over the square root of 2. That same coordinate, you're just flipping it upside down. Now, if you notice, we do have a root 2 in the denominator. We can't have that. We need to rationalize the denominator. Very easy step. You just multiply by root 2 in the top and on the bottom. So now in our numerator, we've got 2 root 2, right? 2 times the square root of 2 is 2 root 2. There's not even a calculation necessary. In the denominator, root 2 times root 2, it's just a 2. The radicals cancel out, and they leave you with just that radicand, whatever was underneath the root symbol. Can I simplify this further? Yeah. Look on the top and the bottom. 2 on top, 2 on the bottom. So this is nice that my final answer is just a square root of 2. So the cosecant at 45 degrees is simply root 2. Look at all this trig you're doing without a calculator. You're all like little geniuses. It's awesome. Questions on this one? Just flipping fractions. All right, everybody. Remember, angles can be in radians. I want you to try this one on your own right now. What's the cotangent of 5 pi over 6? Try to figure this one out. Cotangent of 5 pi over 6. So I gave you a little piece of the unit circle there for you. So you have that angle. So think about the cotangent. It's going to be what divided by what? So we know tangent and cotangent, that's when you're taking the two coordinates and making a fraction, x over y or y over x. For cotangent, it's going to be x over y. angle 5 pi over 6 is down there. So this is the angle or the coordinate that I'm going to be using. For the fraction, I'm going to take the x coordinate, which is negative root 3 over 2, and I'm dividing it by the y coordinate of 1/2, right? X divided by y, dividing by a fraction is the same as multiplying by the reciprocal. So I'm going to take that 1 over 2 and multiply it 2 over 1. The 2's cancel out, and we're left with negative, square root of 3. Anybody else get that? Negative root 3? Couple of you? Okay. Fantastic. Any questions on this one before we move on? That's the end of the lesson. Your homework. To practice this stuff, I want you to try your delta math. So here's the thing. Your delta math, it's very, very easy to just, type this into a calculator or something like that. But you're going to want to use exact values. So, sometimes when you type in one of these angles, it's going to give you like a decimal, and you can't type that in. You need the exactly like root 3 over 2 or 1 over 2 or whatever. So I've got 10 problems for each of the 6 trig functions, okay? 10 of them are going to be in degrees. That's the first one. The next one, exact value of trig functions, are in radians. Still the same idea, you just need to look up that angle in radians instead of degrees. So keep your unit circle handy as you're doing these tonight. Practice each one, just identifying them. And you can just use your copy of the unit circle first to make sure, okay, is this x or y? And I want you to really get into that association of it with like cosine with x, sine with y, and then tangent and cotangent, which one's x over y and y over x. And practice it, just finding that angle on the unit circle. That's it. Think you can do that? Awesome. Talk to you later, everybody.